College Algebra, Section or Chapter Review, Section 3, Geometry Essentials. So we have three objectives. First objective. Use the Pythagorean theorem and its converse. Okay, so what is the Pythagorean theorem? Most people say it is a squared plus b squared equals c squared. But that's not the Pythagorean theorem, that's part of it. We have a big if. If a triangle, a right triangle. So first of all, you have to have a right triangle. And that has legs. What are the legs of a right triangle? Where they're the two sides of the right angle. And the hypotenuse is opposite the right angle. So if you've got a right triangle, use that for your right angle symbol. The legs and the hypotenuse. So if a right triangle has legs A and B and hypotenuse, C, then, and only then, a squared plus b squared equals c squared. So when next time somebody asks, what is the Pythagorean theorem, you should say, if you have a right triangle, if it has legs a and b and hypotenuse c, then a squared plus b squared equals c squared. So what is the converse of this thing? Well, a converse is when you switch the order. Instead, you put the if and put it for the then put it for the if. So you've got to use a little bit of that if, I guess. You have to say if you've got a triangle. If a triangle has sides A, B, and C, and those sides have the relationship a squared plus b squared equals c squared. So now that's where we start with the then part here. And the triangle is a right triangle. So you can determine if something's a right triangle if they give you the lengths of the three sides. A and B, you might want to say that. A and B are the legs, and C is the hypotenuse. The biggest side is the hypotenuse. Okay. Now, there are special right triangles. They call them Pythagorean triples. This is when you've got integers as the legs and hypotenuse of your right triangle. Very famous ones that you'll see in a bunch of problems in your text. The 3, 4, 5, remember the largest one is always the hypotenuse, is a right triangle because 3 squared plus 4 squared does equal 5 squared. 9 plus 16 is 25. Some others that you should probably memorize, if you can draw a really nice triangle like that. The 5, 12, 13 is 12 and 13. That, you can check it if you'd like, but you'll get a right triangle from that. There's another one. Some of these, as I said, are easier to remember. The 7, 24, 25. There are, in fact, a lot of them, and you can even write a program that, if you have a chance, in C++ or in Python, that you can run and figure out which trios, these triples, give you a nice right triangle. There's a bunch of them. And of course, what you might want to remember is any multiple of these also so not only the 3, 4, 5, but if you double everything, the 6, 8, 10, or if you triple everything, the 9, 12, 15, those are also right triangles. They are not the nice Pythagorean triples, the sort of the root of all that stuff, but they work, certainly. So there's nothing wrong as far as that's concerned. It's just they do have this common multiple, 2 and 3. But you can do that with any of those. Now, be a little careful. Sometimes they're going to try to fool you and say that a leg is 3 and another leg is 5. Well, just because it's got 3 and 5 in there doesn't mean it's got to be a 4, because it's got to be the largest side for the hypotenuse. So be careful. If you see a 3 and a 5, don't assume that it's going to be a 4. If you see a 3 and a 4, don't assume that the other one's got to be a 5. They've got to be in that, the largest has got to be the hypotenuse. Now, if we continue with Objective 2, Objective 2 is no geometry formulas. Well, there's probably a bunch of formulas we could come up with, but the most common ones are for area and volume. So let's at least take a look at those, and many of those you know already. The area of a rectangle whose sides are L and W for length and width, just multiply L times W. If you have a square with sides S and S, because both sides are the same, it is S squared. If you have another quadrilateral, which is a little funny, the trapezoid, now you've got this side which you can call the big base, and this side you can call the little base. You also need a hypotenuse, not a hypotenuse, a height. We use an H for that usually. The area of this, you take the average of those two bases. That's 1/2 big base plus little base. And then you multiply by the height. So you can use this same length, width, base times height for almost any quadrilateral if you can set it up that you've got these right angles in the corners. There's a triangle, the sort of generic triangle one, if you know the base, B, and the height, H. Then the area of a triangle is really half of one of these other quadrilaterals. It's 1/2 the base times the height. A circle, let's move up here, circle, radius R, the area of a circle, pi r squared. A sphere has a volume, but we can find the surface area of a sphere if we know its radius. The surface area. There's not a nice name for that. We'll just call it A again. Surface area is 4 pi r squared. Which is sort of interesting. That's all the areas I think we're going to talk about. We also need then some volumes. So we'll leave this on the screen for a minute and then move to volumes. So if we use the same sort of idea, what is the volume of a box or a rectangular solid with the length and width for the base and h for the height? Well, let's just multiply them together. L times W times H. Now you can look at a sphere's volume with radius r. The volume of a sphere is 4/3 pi r cubed. Now, how do you remember the surface area? For me, it's remembering that it's not 4/3, it's just 4. And since it's an area, it's square units, not cubic units, if that helps. What about the volume of a can or a cylindrical solid whose radius is r and whose height is h? It's the area of the base, and this works for almost any solid except for a sphere. The area of the base, like the L times the W, times the height. So the area of the base for this is pi r squared times the height, h. We should mention the surface area of this. I didn't mention that before, but that'll do that in just one moment. There is also, for a cone, and this works for a pyramid also, if this has got an h for height. For any cone or pyramid, the volume is 1/3 of the solid that would go with that. For the cylindrical solid, if you cut this down, cut this out of that, it is 1/3 that volume. 1/3 of pi r squared h. For a pyramid, if the base is a triangle, it's the area of the base times the height, but it's 1/3 of that because it comes to this point. Now, one I might mention here is the surface area of this can. If you'd cut it down one edge, you'd have a circle, you'd have a rectangle, and you'd have another circle. So you'd have two circles of radius r. So this is a pi r squared for the area. This is also a pi r squared for the area. The length is really the circumference, which is 2 pi r, circumference of a circle. And this, of course, is the height. So in order to find the surface area of this can, we have, I guess we'll call this area again. We have 2 pi r squareds plus 2 pi r times h. So you can do that any way you'd like. That's the way I remember that. And that can be very nice too. Okay, so these are some of the formulas, the geometry formulas that you should probably know and be able to use. Leave them there for a second. Copy them down, press pause or something. So now let's go to Objective 3. Understanding congruent and similar triangles. The congruent symbol is an equal sign with a little squiggly, and similar. Wait, did I get that right? Similar, that's supposed to be an I there. That's supposed to be an R. Similar is just this one, I don't know if they call that a tilde, not something like that. Similar triangles. I'm going to run out of room. So, what about congruent triangles? Congruent triangles, if you remember, if you wanted to prove those in geometry, we had angle, side, angle, 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 side, side, angle, side, and side, side, side. We did not have that bad word, angle, side, side. But that's one way to remember that's not one of the congruence proofs. For similar triangles, for it to be similar, the angles are all the same. Notice that to make them congruent, at least one of the sides has to be the same for these two triangles you might be talking about. There is a sort of a SSS, but it's not that these sides are equal. The sides are proportional. And you can do others if you need the sides proportional and an angles equal type thing. But those are the big ones. If the sides are proportional, if the angles are equal, you have similar triangles. So, instead of giving examples for those, I guess exactly, let's go to some examples for everything in this. These examples are from the problems on page 36. This one in particular is number 16. So, once again, how do you get 4 steps out of some of these? That's why I want to use some of these examples to help say. See, the legs of a right triangle, and you can use some shorthand, are given. Find the hypotenuse. That's one step. So A, they say, is 14. B, they say, is 48. Find C. Okay, well, we know from the Pythagorean theorem that if this is a right triangle and if these are the legs, then A squared, or 14 squared, plus 48 squared has to equal C squared. Well, 14 squared is 196. You might have to use a calculator. I did, I guess. 48 squared, 2304. That's C squared. Together, that makes 2500 being C squared. So, what is C when you take the square root? Well, you can use your calculator if you want, but you know the square root of 25 is 5. And if you put just 1 0 on that, not 2, then 50 times 50 is 2500. And so, this must be 50. And although I squished this in here, there's 1, 2, 3, maybe even 6 steps on this thing. It's probably better to make sure whomever's grading this, like me, sees that you have all those listed vertically. But draw a picture if you need to. Pictures are usually worth 2 steps. Oops, that's a crazy, terrible right triangle. So this is, let's say this is the longer, 48 and 14, and this is the hypotenuse. Just to remind yourself, that's another step. Okay. How about number 24? Given the sides of a triangle, determine if it is a right triangle. Now, sometimes you don't want to write down the whole problem because it's pages worth of stuff. But some of these are just a little bit long. It's not bad. Given the sides of a triangle, determine if it is a right triangle. Well, that uses the converse, and that's one of the things you can try or you can talk about. Use the converse, right? Converse, that's an E, of the Pythagorean theorem. So, what are these? We're given the sides are 4, 5, and 7. Well, the largest side has got to be the hypotenuse, if this is a right triangle. So these are the 2 legs. So a squared plus b squared would have to equal c squared if this is a right triangle. 4 squared plus 5 squared, does that equal 7 squared? And maybe even put a little question mark here so that whoever's grading this says, oh, he's not sure of that yet. 16 plus 25, does that equal 49? So 16 and 25, that's 30, is 41. Does that equal 49? Question mark. No. So this is not a right triangle. So let us continue. How about number 34? Find the volume and surface area of a sphere with a radius 3 feet. Might as well write that down. That's a step. The volume, find it, and surface area of a sphere with radius 3 feet. So the volume is 4/3 pi r cubed. The surface area, sometimes they call it S, I'll call it S, which is just 4, the numerator, pi r, because this is area, now it's square units. So the volume is 4/3 times pi times 3 cubed. So the volume, now this 3 will get rid of one of those 3's. So this will now be squared. And this is 4 pi, 3 squared is 9, right? Or the volume is 36 pi. Surface area is 4 pi 3 squared. Oh, that looks familiar. So it is 9 times 4, or 36 pi. So the surface area is the same as the volume? No, that's why they give you the 3 feet. Because this volume is cubic feet. That's a whole lot bigger than square feet. 36 pi square feet is really just a surface. This is a huge volume of stuff. So it's pretty tall as well as just that flat area. Okay, let's do one more. Number 52. Okay, this one's a word problem, so we're not going to write down all the stuff, but we are going to draw a picture because that's worth 2 points. And it is the problem that deals with the Bermuda Triangle. It goes from Fort Lauderdale, we'll call this F, to San Juan, Puerto Rico, to Hamilton, Bermuda. This is the Bermuda Triangle. Now, on a map, they measured and find this bit to be 57 millimeters, this to be 53.5 millimeters, and this to be 58 millimeters. In real life, I don't know which one's actual. This Bermuda Triangle, Fort Lauderdale to Hamilton, Bermuda, to San Juan, Puerto Rico. We don't know what these are. Let's call this X and this Y, but we do know it's 1,046 miles from Fort Lauderdale to San Juan. So that gives us our ratio, the 58 to the 1046. That's the ratio we need for the other sides, because that's the same ratio of 57 to x. It's the same ratio as the 53.5 to y. So we're just going to cross multiply and divide by the third to solve for x. Cross multiply, divide by the third to solve for y. For the 57, when we cross multiply and divide by the third, we get 1,027.96 miles. We should probably round that, since they did that to the nearest mile. It looks here 46. This will be 1,028 miles. This is from Fort Lauderdale to Hamilton. And for y, we'll get 964.84. Round that to the nearest mile. This is the Hamilton to San Juan, and it'll be 965 miles. Boy, see, you can get steps. You can make your stuff look really nice. That's chapter review, section 3. Now you can do your problems.